In this video, we're going to look at an algorithm for reversing a string. There are a couple of different ways to solve this problem. One way is to iterate the string, add each character to a stack, then pop all the characters that will come out in reverse order, so we can combine them into a new string. That's one way. Another way is to iterate the string from the end, read each character, and add it to a new string. I prefer this approach because it's simpler and we don't need to create a stack. So it's more efficient in terms of the space. Plus, it gives us the same performance. So let's see how it works. We add a new method here, public static string, reverse, and give it an input string. So first we declare a string. We call this reversed. Initially, we set it to an empty string. Then we iterate over our input string from the end. So for I, we set it to str.length. As long as I is greater than or equal to 0, we decrement it at each step. Now here we should append the current character to the reversed string. So reversed plus equals str.char at I. Okay? And finally, we return the reversed. So this is the basic idea. Now, there is a hidden problem with this approach. As you probably know, strings are immutable in Java and in most programming languages. That means when you create a string object, you cannot modify it. Any changes you make to that string results in creation of another string object in memory, so the original string will remain unaffected. Now look at this line over here. Every time we append a character to the string, we're creating a new string object, and all the characters in the current string are being copied to the new string. As our string gets longer, the number of characters that should be copied to the new string object also increases. What is the time complexity of this operation? It's O of n, because it grows linearly and in direct proportion to the size of the string object that gets increased at each step. So here we have an O of n operation. Now look at this loop. With this loop, we're iterating over our input string. This is also an O of n operation. So O of n times O of n gives us O of n squared. That is the time complexity of this method. So this method gets really slow as the size of our input string grows large. What's a better way? Well, in Java, we have a class called string builder. We can use that to create mutable strings. So we can append each new character that we read without the overhead of recreating another string object in memory. Let me show you. So instead of using a regular string, we use string builder. Okay, now we cannot set this to a new string. We have to set it to a new instance of string builder class. Okay, now instead of using the plus equals operator, we have to call one of the methods of the string builder object. So reversed.append, and here we pass str.char at I. This is how we append a new character to our string builder object. Now, this is going to be an O of 1 operation. O of 1. So with this simple change, we have reduced the time complexity of this method from O of n squared to O of n. That's much better. So let's remove this comment. Now, finally, we need to return a string, not a string builder object. And that is why we have this compilation error. This is very easy to fix. We simply call toString. Now let's test our implementation. So back in the main class, I'm going to call reverse and give it a string like blue. Let's store the result in a string object called reversed. And here we print reversed on the console. We got an exception. String index out of range. So let's see where this happened. We got this exception because I forgot to add a -1 over here. Let's run the program one more time. Okay, our blue string is reversed. Beautiful. What if we have an uppercase string? Obviously, it's going to work, but it's better to test it. Beautiful. Now, what if we pass a string with a white space? So far, so good. What if we pass an empty string? That is good as well. What if we pass null? We get a null pointer exception. So to fix this, in this method, first we check to see if str is null, then what should we return? We can return null, but I don't like this approach because it can cause a null pointer exception somewhere else. For example, what if we go back to our main class and instead of printing the reverse string, we want to print its length. Now we'll end up getting a null pointer exception on this line. That is not good. A better approach is to return an empty string. This will prevent a null pointer exception from being thrown somewhere else. Now if we run this program, we get 0. Beautiful. So this is how we reverse a string.